Hi, this is Larry Singhan. I'm just doing a quick overview of my Lab 8 Experiment 2. As you can see, I have my setup here on the breadboard. It's a little messy, but I have the LED output. I have the debouncing circuit for the switch. I have my microcontroller, and I have the rotor encoder hooked up to the microcontroller. So the idea is that if I twist the rotor encoder, I'm sorry, let me fix this. If I twist the rotor encoder clockwise, the LED should get brighter. Boom. You can see that. Perfect. If I twist the rotor encoder counterclockwise, the LED should get dimmer. You can visually see it. That's fine. That's perfect. Let's make it a little brighter. And if I press the switch on the rotor encoder, the LED should go back to turning off, being off, basically. So press the switch, LED turns off. Perfect. So that's the basic functionality. The only other things that I do want to go over is figuring out how I solved the rollover issue with the timer 2 on the rotary encoder. So right now we're at the default state, and I'm printing the the values of the timer 2 and the PWM duty cycle. As you can see, timer 2 value is back to 0. The duty cycle is back to 0. As a reminder, the duty cycle controls the LED brightness. So if I go and I twist the rotor encoder counterclockwise, it's supposed to be rolling over, and the idea is if you don't have any way to correct that, the LED should get back to its maximum brightness, basically. So if I twist this counterclockwise once, there you go. It didn't get back to its maximum value, and we can see it here. There's that 124. As you can see, so it did detect, the code did detect that we rolled over, but if you notice, the PWM duty cycle is still 0. So I'm gonna twist it counterclockwise again, so you can see. Oh, there you go. But the duty cycle is still at 0. And I should mention the timer 2 ranges from 0 to 127, and 124 is the 4 is basically one step below the maximum value, one rotor encoder twist before the maximum value. So that's perfect. So that works. Let's test the maximum value. The rollover from 124 in this case to 0. I'm twisting until I reach. So right now if you see, the timer 2 value is at 120. One more twist, we're at 124. The PWM output is at approximately 63K, and one more step, one more turn of the rotor encoder will cause the duty cycle to go above 65K, which is its maximum value. Okay, so I'm just gonna go ahead, and since we're here at the maximum value, I'm going to go ahead and twist this once to clockwise to see if it rolls over, and the LED should turn off, but it doesn't, which is perfect, because that means if you take a look at the code over here, you can see that timer 2 value is 0, so you can sort of see it here. And I have a code that says, it prints, it says we rolled over clockwise. The duty cycle is still at 63K, so it's a little hard to see, but I'm going to twist the rotor encoder clockwise again. So we're at the max value, twisted, it detects the rollover, boom. A duty cycle is basically approximately still at the brightest, but we maintain our duty cycle basically after our maximum duty cycle, even if we roll over. So I can twist it by a lot. So we rolled over to 16, but the PWM duty cycle is still 63, approximately 63K, like one off from the maximum value, but it's still the same. So that the idea here is we're at the brightest. Even if I keep going clockwise, it should not go back to 0. The LED should not turn off. But if I do go counterclockwise, the LED should start getting gradually dimmer and dimmer, and it is. Up there you go. And you can sort of confirm that here as well. And now we're back to 0 since I twisted it to 0, all the way back to 0. All right, thank you for watching.